Hello, this is your instructor Pitchford in math, Instructor Stanley Pitchford, math man, author, tutor, teacher, and poet. And I'm about to put on my website another math lesson. This is an elementary algebra topic on a factoring strategy. This strategy will help you factor better when you factor in polynomials in any types of situations. So the instructions must say factor or factor completely. Here we go. Let's get to it. Now, this is called a factoring strategy. That's what the title is, a factoring strategy. So the very first thing you do is find the greatest common factor of every term, of all the terms you're looking at. Usually it's 1 term, 2 terms, 3 terms, or 4 terms. Sometimes more terms. But you pull out the greatest common factor, or the GCF. Usually the instructions say factor completely. Just like that. Factor completely. So factor completely is instructions. So you just got to find a GCF of all the terms in the polynomial. Then number 2, after that, do a term count. So if you do a term count, if it's 4 terms, chances are you got to use FBG, which is factor by grouping. And I'll explain that later. If it's 3 terms, it's going to be trial and error AC method, whichever method you use. There's a trial and error method and there's the AC method. And we'll explain both of those probably a little down the road. If it's 3 terms. Now if it's 2 terms, you got 3 choices to choose from, three different directions to go. There's the difference of squares formula where both of the letters are squared and there's a subtraction in front of it. Remember, that means difference, so that's subtraction. So that'll be x squared minus y squared is equal to x plus y in parentheses times x minus y in parentheses. So basically the x and the y both are in the parentheses, but the plus sign is the difference on both of them. Sum of cubes. Well, that's what it is. The plus sign is in the middle, and it's two variables that sum of cubes. These are 2 perfect cubes. So that's x cubed plus y cubed. All right, so the formula is a 2 by 3. So it's two terms by times 3 terms. So it starts off the same sign as the formula starts off. Plus there, plus there. Even when you're doing difference of cubes, it's minus there, minus there. But as you go across, notice how the 2 signs change here when you're multiplying the x, y. But the good news is the last term sign in both formulas are the same, plus. So when you're doing the sum and difference of cubes, the only thing changing is the first 2 signs, but the signs start off as the same as the factoring method. So that's not so hard to remember. I mean, this is not so hard of a formula to remember right here, these 2. And this was not so bad. Remember that there is no sum of 2 squares. So there's no sum of 2 squares. So there is no sum of 2 squares, right? There is no sum of 2 squares. So look at these examples to help you out. These answers are going to be what's called prime, because the only factors these things have is 1 and that thing itself. So when you look at this right here, it says the structure say factor completely. You got x squared plus 1. Well, you can't square this because there's no such thing as a sum of 2 perfect squares. And you see the plus sign dead in the middle between the numbers. So you can't break that up, right? There's no way you can factor that. If it was a minus sign there, then it'd be differences of squares, then you'll be using the formula. So yeah, it can work because the x is squared and the 1 is 1 squared. So y will be replaced with 1 here, and you'll just walk through this formula using y equal 1. That's if it was a minus there though. So that's why this answer is prime. Moving on to the next one. X to the 4th plus 2. Well, first of all, is no such thing as a sum of 2 squares. So 2 ain't even a perfect square. So you can't even really do nothing with this one. So we're moving on to the next one. Okay, x cubed plus 4 cubed. But 4 is not a perfect cube. So you can't really do nothing with this one either. Right? Because 4 is not a perfect cube. What is a perfect cube? That would be like if you take a number times itself 3 times and you get another number. Well, 4 nothing times nothing. The same number times itself 3 times don't give you 4. Right? What about 8? Well, 2 cubed is 8, but clearly it starts off x squared, right? So it's a 2 right there. So that means x squared plus 8. Well, 8 is not a perfect square. And it's no sum of 2 squares anyway. So we're going to the next one. That would be prime 2. All right, that looks like it's all. Oh, one more. Well, here's a 3-term one. Now this one is prime, and it's a trial and error. It's 3 terms, so you have to use trial and error. But it's no real way to use trial and error here, because if you look at the ends of the problem, well, the x squared has coefficient 1, and the number already at the end is 1. But there's no way you're going to get 7 with just 1 and 1. So that's why this is prime. You can't do nothing with that. You can't even factor that. All right, so that's a little small mini lesson on primes. So what we're going to do at this point is talk about factor by grouping. One of the factor techniques. Remember, when you got factor by grouping, you got to have how many terms for this to happen? 4. So let's go back to that. Factor by grouping, it was way up here. So I'm going to go over the rules with factor by grouping. So if you got 4 terms, factor by grouping is probably available. So here go the rules. We can go to that right now. Well, I'm just going to explain by example. I'm not going to write the rules down. Usually, if it says factor and you got 4 terms, chances are it's factor by grouping. So let's pretend like this is our problem. Right? 15x cubed minus 9x squared plus 35x minus 21. Right? Well, what you got to do is group the terms together to where you can pull out the greatest common factor of the first 2 and then the second 2. So that's why I have them underlined. I have the first 2 I'm going to work with underlined, and then the second 2. So on the next line here, basically what's going on is, on the next line here I have so basically on the next line here we got so like I said before, basically on the next line we got we got 3x squared, and in parentheses you got the 5x minus 3, because basically what we did was, that says 15x cubed plus 9x squared. And what we have to do is factor out what's common in these 2 terms. Now we can pull out 3x squared, because there's at least x squared in both of these terms. That says x cubed, and this is x minus 9x squared. So we pull out 3x squared, and then what we have left over, you do the long division on. So you do this over this. So 15 over 3 is 5, and you got x cubed, and you got over x squared. Well, I got 3 up here, 2 down here. So in order for me to get this, I need 1 more x. So that's why I know x has to go right here. Or you can do the division. X cubed over x squared is just x. So you do the same thing straight across the board. So you do this with this number. You divide this over that. And watch your signs. Negative divided by positive is still negative. That's why you see the minus in front of the 3. And you go to straight across and pull out the greatest common factor again. Well, which is going to be 7, right? And then what's going to happen is, what's going to be neat is these 2 things in parentheses ought to be the same if you're doing FBG. Right? So now you got to look at the big picture. So the greatest common factor of the big picture here in this line right here is this stuff in parentheses. So that's why we pulled it out. And so what do we have left? The stuff that's not in parentheses, right? So 3x squared and then the plus 7, right? And this will be the answer right here. These 2 multiplied. So you just leave it in factor form. So you have to pull out the GCF once in the first 2, once in the second 2, and then the GCF out of the big picture on this line right here to get the answer. So that's how factor by grouping go. Right? So factor by grouping is not that bad. What if you have a difference in squares problem? Well, the difference in squares problem be like something like this. Factor x squared minus 9. Well, you got to look at this and say, okay, clearly this is going to work because That's x squared, which is a perfect square. And that's 9, which is 3 squared, which is a perfect square. So this is a difference of 2 squares, right? So that means we can use the formula where, in this case, 9 is going to be substituted here for 3 and 3, because the perfect square on this is 3. So just like in the formula we had earlier, you're going to use this formula, the difference of squares formula, but instead of y, you're going to have 3 where the y is, right? So what a y here is in the problem here, you're going to have 3 right here where the y's are. Everywhere you see y, you're going to put 3 in the problem, right? So that's what's going on here. So that's why the factored answer is this answer right here. So x is x, but wherever you see y, usually you're going to put 3, because y squared is usually right there. Moving on. Your instructions will be FC, factor completely. Factor all the polynomials completely. And it'll look like, if it looks like this, 2x squared minus 18, well, the first thing you do is number 1 here, right? Look for the greatest common factor. Find the greatest common factor of all the terms. So when you look at this, we go back to this and look, you say, hold up. Both of them numbers are even. So I can at least pull out 2. But could I do anything better than 2? No. Well, they're both even, so I can pull out 2. When I pull out the 2 and I do the long division again, I got the x squared left over. And then when I take 2 into 18, I get minus 9. So, but when I look at this again, it says factor completely, so I may have to factor more than once. So I got to look the factor material again, the x squared minus 9, and see if I can do anything else. Of course there is, because this looks just like the one we just did. So this difference of 2 squares, right? So the net final answer will be 2, and in parentheses you have those other things set off in parentheses, and that's the final answer, this thing right here. 2 times x plus 3 times x minus 3. So that's how factor completely would go. Sometimes you got to factor more than once. So, all right. Now, we'll do trial and error on the next lesson. Finish up factoring strategy. But thanks for listening in. This was your math help tutor for elementary algebra topic of factoring strategy. We'll do part 2 later on trial and error. Peace. Talk to you later.